So now let's look into the another type of data encoding, which is binary encoding. So binary encoding is a type of data encoding technique used in machine learning and data analysis to convert categorical variables into binary representations that can be easily processed by machine learning algorithms. In binary encoding, each category is represented by a binary code, typically a sequence of zeros and ones, where each digit corresponds to the presence or absence of a particular category. When I say it uses zeros or ones, you may think that it is similar to the one hot encoding, but not exactly. So it uses the principles of label encoding and also one hot encoding. What is that? We will see. Okay, so now in binary encoding, the categorical feature is first numerically encoded using an ordinal encoder, which assigns a unique integer codes to each category. Then these integer codes are converted into binary representation, where each binary digit 0 or 1 represents the presence or absence of a particular category. So the binary representation is then split into separate columns, with each column representing a binary digit. So now let's understand the same binary encoding using an illustration or animation. Let's say we have a data set of color, a data set with a color category. No, variable name is color, and this color has three categories inside that. This column, this color column containing this, I said, category. It's a color. Basically the color, the variable name, the column name is color, and this consists of three categories. This column containing category values, categorical values, red, green, blue. Now we want to convert these categorical values into binary representation using binary encoding. That's what is our target. In this, the first step in binary encoding is using binary encoding. We first assign numerical codes to each category like this. You see that? Like ordinal, ordinal encoding 0, 1, 2. Just you give a numerical value. Of course, here there is no order. You can say that it's simply just giving you are assigning the numeric value 0, 1, 2. Okay. So that's the first step. First step is to assign numerical codes to each category like this: red 0, green 1, blue 2. There ends the matter. That's the first step. Once the first step is done, then the second step is then we convert these numerical codes into binary representation, and this is how it will be converted. So red means 0. So 0 in binary representation is 0, 0. And green in binary representation is 0, 1. And blue, it's 2 in binary representation is 1, 0. So that's the second step. Once second step is done, now we finally split the binary representation into separate columns, one for each binary digit. So here I have a double digit binary representation. That's why I have splitted this into two binary variables, binary dummy variables. So 0, 0, 0, 0, 0, 1, 1, 0. And this is how your category has been converted into a binary, a dummy variable with binary values, zeros and ones. That's what we are saying here. So I'm repeating this again. The categorical feature is first numerically encoded using ordinal encoder. You see that? That's what we did in our first step. Then, which assigns unique integer codes to each category. We did it here. Then these integer codes are converted into binary representation You see that the each integer code is converted into the binary representation where each binary digit 0 or 1 represents the presence or absence of a particular category. So now the binary representation is then split into separate columns with each column representing the binary digit. And this is what is our binary encoding. So now let's take a simple example to understand this in a better way. Binary encoding. And so let me take the data here. Where is that? I'm going to call up the df1h. Just a minute. I need to take up somewhere. It should be. Yeah. This is what the data I'm going to use here. Let me bring it here. So let me call this data as dfb. dfb. So dfb for me. Yeah. This is what is our data frame. It got 64 rows and one column. That's animal. Okay. So now let's perform binary encoding using binary encoder. So for that we need to import this binary encoder from category encoders. I hope you have installed the package category encoders. So let me import this first from category encoders, and from the category encoder package import binary encoders. And if you want to see what all you have in the category encoders, you can just simply import category encoders, and then you can just say, just a minute, as ce and c dot. Now you have base and encoder, backward difference encoder, and cat boost encoder, count encoder, gray encoder, hashing and hashing encoder, helmet encoder, gemstain encoder, and one hot encoder, ordinal encoder, polynomial encoder, quantile encoder. You have lot. So this consists of lot of encoders with it, but at this moment we'll be using only binary encoder. So that's the reason the specific binary encoder module method has been imported from the category encoders. Okay. Now, so let's perform binary encoding using binary encoder. So let me say encoder, this is equal to binary encoder. So it's done. Now it's time to fit and transform our column using the binary encoder method. So let me call this data. What did I say here? What's the variable name I have mentioned? It's dfb. So dfb, let me put it here. So dfb underscore encoded is equal to encoder dot, obviously I have to give fit and transform, and the data for me is dfb. Yeah, it's where it is, dfb. Yeah, here it is. So that's it. Your data encode, now binary encoding is done. Now let me concatenate. So before we look into that, or else if you want to see, you can just look into the data here. So dfb encoded, and here is your encoding. So now let me concatenate both. So dfb encoded, dfb f is equal to pandas and concat and dfb and dfb encoded, and access is 1, and dfb f, and here is the binary encoded data. So total it has 64 rows and three new columns were added to this. Before it was 64 by 1. That was the shape of this data frame. But now the three more columns were added. Now, so whatever I told you this way in this fashion that so the first step would be binary encoding. The first assign numerical codes to each category. Then it will be converted into the binary representation. Then finally it will be broken into the different dummy variables with the binary numbers. That's what we said, correct? So now I'm gonna re-engineer this and I'm gonna show what is gonna happen. So for me, so for the dog, for dog it is 0, 0, 1, correct? 0, 0, 1, correct for dog. So now, of course, there is syntax error. This is okay. Uh, Let me just put it here. Sorry. For dog it is 0, 0, 1, and for sheep, let me take the values from here. For cat is equals to 0, 1, 0, and for sheep it is equals to 0, 1, 1, and for lion it's equal to 1, 0, 0, and for the horse it's equal to 1, 0, 1. So now it's time to re-engineer. Okay, reverse engineer. Let's do the reverse engineering. So what I'm gonna say is simply, so the dog numeric value, the numeric code that we have assigned is equal to 0 B 0, 0, 1, and print numeric code is dog. That's it, it's one, correct? Now let me do it for others. And here this time what's that? It's 0, 1, 0, correct? And this is cat. Let me put the cat here. And here is that 2. So 1 has been assigned to the dog and 2 has been assigned to the cat. Now let's do it for others too. It's 0, 1, 1, and this one is sheep. And let me put it here. Sheep. It's 3. 3. Then same applies to the line. And by this time you would have got, so that would be 4. Line. And it's 4. And final one, horse. So numeric code for this would be 1, 0, 1, and its horse, obviously it would be 5. Let me call up this. That's it, it's 5. Hence it proves my point, whatever I've said before. So what we did, what this module did was dog was allocated with 1, cat was allocated with 2, sheep was allocated with 3, lion was allocated with 4, horse was allocated with 5. This is nothing but your label encoding, correct? Label encoding. So that's what we did here. So once it is done, then it was converted into the binary representation. Once it was converted into the binary representation, then it was broken into 3 dummy variables. That's what is our binary encoding. We did it in 3 steps.